Hello everyone. Here we will discuss about traveling salesperson problem by using least cost branch and bound method. The traveling salesman problem, already we know the scenario that the salesman will start from the hometown and he has to visit all the cities allotted to him for performing the sales. Then after visiting all the cities, he has to go back to his hometown. So here, when he is planning for the tour, he has to he has to minimize the traveling cost to save the money. For that, we have to show him the shortest path to visit all the cities in his tour list. So here, to find out the shortest path, we can use least cost branch and bound method to minimize the cost. So in this least cost branch and bound method, we will use cost matrix to perform the calculation for minimizing the cost. The branch and bound method is minimization problem, so we can use it for minimizing the cost for traveling to all the cities. First, initially, we will construct the cost matrix from the given structure of the weighted graph. So here, a to a, there is no path, so we are making it as a infinity. And another one is, here we should not give 0. Okay, one of the thing we should remember, we should not give the 0, because here we unknown about the distance to same city, so that's why we are giving the infinity. Some other problems like dynamic programming or greedy method, we may use 0, but here we will use the 0 as a lowest value for calculating the cost. So if you give the 0, then it will become as a minimum cost. So to avoid that, we are using the infinity if there is no path to the cities. Okay, so a to a, there is no path, we are giving the infinity. And a to b, here this is 4 units of cost. And a to c, here we are having the 12 units of cost. And for a to d, we are using the 7 units of cost. So like that, we are constructing the cost matrix for from the b and from the c and from the d to all the cities. So finally we got the cost matrix in this values. Now the first step is, we have to calculate the reduced matrix. So to calculate the reduced matrix, we have to follow row reduction and column reduction. So row reduction, in the sense, we have to select minimum value from each and every row of the cost matrix. Then we have to perform subtraction with that selected minimum value. For example, here the 4 is the minimum value in this row, so 4 is selected. And 5 is the minimum value in this second row, so 5 is selected. And for the third row, 6 is the minimum value, it is selected. And here 2 is the minimum value, we have selected. So as per this statement, minimum value from each and every row is selected. Now you have to perform the row reduction by applying subtraction. What is that subtraction to be performed? Here the minimum value is selected, so from each and every element we have to perform the minimum element. So for that, here infinity minus 4, infinity minus 4 is again infinity, so that is given here. Then 4 minus 4, it is 0. 12 minus 4, which is 8. 7 minus 4, which is 3. Like that, second row, here we have selected 5 is the minimum value. Then for each and every element we have to apply the subtraction. 5 minus 5, which is 0. Infinity minus 5, both are infinities. 18 minus 4, which is 13. Then the third row is minimum value 6, so 11 minus 6, which is 5. And two infinities are there, infinity minus any value infinity. 6 minus 6, we are getting 0. Like that, fourth row, here 10 minus 2, which is 8. 2 minus 2, 0. 3 minus 2 1 and infinity minus 2 infinity. So now we have performed the row reduction by applying this subtraction. Likewise, we have to perform column reduction by taking minimum value from each column of the row reduced matrix. So after row reduction we got this matrix. From this we have to perform the column reduction. So in this column we should select minimum value, that is 0, which is selected. Here also we are having minimum value 0 selected. Here also we are having minimum value as 1 selected. In this fourth column minimum value is 0, it is selected. So again we have to apply the subtraction column wise. So from this column wise subtraction, here look at that minimum element is 0, so 0 minus 0, which is 0, infinity minus 0, which is infinity, like that 5 minus 0, which is 5, 8 minus 0, which is 8. So like that this column all are zeros, so we will get the same elements. Here we are getting 1 is the minimum element, so 7 minus 8 minus 1 7. Here both are infinity, and 1 minus 1, which is 0. Then here minimum element is 0, so nothing will change for this column, so same elements for this columns are repeated. So this is the reduced matrix after first step. So here from the row reduction we got total value 2 plus 6 8 plus 5 13, 13 plus 4 17. So row reduction, by row reduction we got the cost is 17. By column reduction we got the value is 1, right? So 17 plus 1 is now 18. So total reduction by applying the row reduction and column reduction we are getting the 18. So initially for the root vertex the cost value is unknown. Now we got the cost value as 18. So 18 is the cost value for the node number A, so we have updated as a 18. Now we have to explore this node. What are the possibilities here? So now the A is now have the cost with 18. Now we have to explore that. So to explore that, A is there. A is having three possibilities. One is B, and another one is C, and another one is D. So three possibilities are there. We have to check all the possibilities. First we will select the first possibility is B, right? So A to B we are selecting the path from vertex A to vertex B. We are giving the node value as a 2 here, right? Node number is 2 here, so that is given. Now from the reduced matrix here, which is given here, okay, which is given here, we are selecting the path from A to B. So for the A to B we have to select the value of this position, right? So value of this position, then that is 0. Then we have to perform the value row of A comma column B. So this is the A vertex A and vertex B. So we have to make that position, okay. Row, entire row A should be a infinity, so this is the row A. So earlier this structure is this one, so entire row should be make as a infinity, and B, so entire column should made as a infinity. So this is made as a infinity, this column also made as a infinity. And the third constraint is we have to make m of b comma a as a infinity. So why we are making that m of b comma a? So once you are going to the node 2, that is B, you will not come back to the A. So there is no path, okay. Once you visited, again you should not go back to the A. I mean we cannot visit two times, only one time you have to visit. So we have to make this position as infinity. B comma A is this position. Earlier that value is 0, now we are making this position as infinity. So after that we got the cost matrix in this values, with this values, okay. So after that again we have to find out the cost for the node B. For that we have to perform the reduction, total reduction. So here this is the resulted matrix you got, cost matrix, after performing these three steps. For that we have to apply the row reduction. Here the infinity is the value, so we don't know that value, unknown value, which is giving as a hyphen. Here minimum value is 13, which is selected. Here minimum value is 0, selected. Fourth row minimum value is 0. So now we have selected the minimum values from all the rows. Then perform the subtraction with this element for each and every element of rows. So when you are applying the row reduction, here nothing will be happen here. So all these three are infinity. The 13 minus 13 is 0. Then here 5 minus 0, 5, that is given here. 0 minus 0 is given here. Here 8 minus 0, 8, and 0 minus 0 is 0. Infinity minus anything is infinity, which is given here. This is the matrix after the row reduction. Likewise, we have to perform the column reduction for this matrix. So from this we have to select again minimum elements column wise. For this column minimum element is the 5, which is selected. For this column there is no minimum element, and the third column minimum element is 0, as it is selected. Fourth column minimum element is 0, which is selected. Again you have to perform the subtraction column wise. Okay, so here first column 5 minus 5, which is 0, and 8 minus 5 is 3. So infinity minus anything is infinity. Like that, second column no change. Third column, since it is 0, no change. Fourth column also, since it is 0, no change. Even if you are applying the 0 minus 0, you will get 0, right? That is the thing. So this is the final matrix we have got after reaching the node B. This is the cost matrix of node B. Now we have to calculate the cost of 2. So here cost of 2, we already spent 18 units of cost for A to B. Okay, from reaching from A to reaching B, we have spent 18 units of cost. After that, here we have to calculate the cost to the B. So 18, right, that is the cost of 1. Then total reduction is here 13, plus column reduction here 5. So 13 plus 5 is 18, so that total reduction is 18. Then m of a comma b, m of a comma b, we have value here, that is 0. So we have substitute the value 0, and total cost is 36. Now we are updating the cost of B is now 36, so which is updated now. After updating the this cost of node 36, another possibility is A to C. So for the A to C, again you have to take the previous slide. There is the cost matrix of node A. So here the cost matrix of node A we have selected. So then from the A to C, this path, for this A to C, what is the cost we have to spend? So for that, what we have to do, from the reduced matrix of node 1, this one, we have to make that position m of a comma c, right? We have to select that value. So that is available here, this value a comma c of node 1 cost matrix. Okay, after that we have to make a comma c, row A to be infinity. So entire values of row A to be infinity of that node 1 of matrix, and the column C to make as a infinity of the node 1 matrix. Then after reaching the C, again you should not visit back from the C to A, that should not do. So what we have to do, we have to make that position as infinity. So C comma A, this position as make as infinity. Earlier that value is 5, now we made as a infinity. Okay, after that we got the resulted matrix. Now we have to perform the total reduction by applying the row reduction and column reduction. Here nothing is minimum element, here 0 is the minimum element, here 0 is the minimum element, fourth row 0 is the minimum element. When you are subtracting any value with zeros, you will get the same elements, so nothing will be changed in this matrix. So same elements are repeated again, and you are performing the column reduction. So this column is also 0, this column is also 0, here infinity, here this column is also 0. So when you are subtracting with any value with 0 column wise, again you will get the same elements which is given here. This is the cost matrix of node C. Now we have to calculate the cost of node C, right? So cost of node 1, already we spent 18 units. Then to reach the C, we have to spend some amount, that is the total reduction. So total reduction is here 0, here also 0. So 0 plus 0 we got 0, right? And the m of a comma c, we got here 17. So finally we got the total cost is 25. Now we are updating the cost of node C is 25. After updating the node cost 25, again we have to check another possibility is A to D. So again we have to take the node 1 cost matrix. So from the node 1 cost matrix we are going to the node D. So here when you are going there, we have to select the m of a comma d value from the node 1 cost matrix. Okay, node 1 reduced matrix, right? Reduced cost matrix, right? So now m of a comma d is 3, and after that we have to make that row A, okay, row A to be infinity, and column D as infinity. We made this both changes. Then m of d comma a, this position to be made as a infinity. So this is the resulted matrix. For this resulted matrix, apply the total reduction, row reduction, and column reduction. So here row reduction, we are selecting the minimum element, and here 0, here 5, here 0. So now row reduction is 5, and perform the subtraction. Here in this row, two rows, nothing will be changed. Here the 5 minus 5, this position is becoming 0, remaining all are infinity, nothing is changed. Then D, so here 0, so nothing will be changed, so just same elements. Then perform the column reduction, all columns are having zeros, so nothing will be changed, same matrix will be the reduced matrix for the node D. So total cost is here, cost of node 1 18, and total reduction is here 5, and here it is 0. So 5 plus 0 is 5, so which is given here m of a comma d, that value is given here, so 3. So now total value is 26. Now we are updating the cost of 4 is 26, right? After making this, here we have to select least cost node among the 36, 25, 26. Least cost is 25. So we have to explore only the node C. You can explore B and D also, but you will not get the optimal cost, that is the minimized cost. So you can kill this two paths and explore the node C. So now we are going to explore the node C. A is already visited, C is already visited. So only remaining two possibility is B and D. So we are taking two possibilities B and D. Here we are giving the node numbers 5 and 6. So now from this we are going to explore the node 3. Possible paths are A to C to B, that's what given here. Then another possibility is here A to C to D, that is given here. So we have to find out the cost for these two paths. So this is the reduced matrix at step 2, previous step, the node number 3. So node number 3 is here, okay, this is the cost matrix of node number 3, right? So infinity 0, infinity 8, okay. So this matrix we are taking infinity 0, infinity 8, and all the values are same for the node number 3, that is the C. So from that, now we are making the path, okay, we are making the path to B, okay. So A to C to B, so A to C to B, here we are making the path from C to B, okay. Already we reached the A to C, now C to B. If it is the case, from the reduced matrix of node 3, we have to make we have to identify the value of m of C comma B, okay. So here m of C comma B, this one, this is the row, B is the column, so this is the value, we are taking that value m of C comma B, that's what infinity, and we are making this C row, the entire row is infinity, and column B, is infinity. So we made these two changes. Then m of b comma a. So here after reaching b, again you should not visit a. Okay, you should not visit back a, because only one city has to be visited only once. So again you should not go back from the b to a, right? So we are making that position as infinity. So b of b comma a is this position we have made as a infinity. This is the resulted matrix after these changes. Now we have to apply the total reduction by using row reduction and column reduction for this resulted matrix. So here all are infinity, and here 13 is the minimum element. Here all are infinity, and here 8 is the minimum element. So here by row reduction you are getting the cost is 21. Now apply the subtraction. So here all are infinity, 13 minus 13 which is 0, and here 8 minus 8 0, remaining all are same. Then apply the column reduction. So here also 0, here also 0, here all are infinity, all columns are infinity. So column reduction is 0. So total reduction is here 21 plus 0 is 21. That's what given here. And the cost of 3, so here the cost of 3 is 25. So that cost is 25. So and m of c comma b is infinity. So it's infinity. So infinity plus any value is infinity. Why it is coming like this? You look at that a c b. Okay, from the c to b there is no path. You look at that, there is no path directly to the b from c. So that's why we are getting infinity. From the given graph itself you can identify, but it is mathematically proved that there is no path from c to b, so it is infinity. Then what is the next possibility? So the cost of the node 5 is updated as infinity, and another possibility is c to d, right? So when you are updating the c to d, again you have to get the value of m of c comma d of the matrix of node c. Then you have to make this row c and column d as infinity. So row c and column d as infinity, and m of d comma a. After reaching the d, again second time you should not visit the a. That's why we are making this path as infinity. So m of d comma a, here this position we are making as infinity. Now we got the resulted matrix. Apply the row reduction and the column reduction. Here all are infinity, here 0, here infinity, here 0. So you will get the row reduction is 0. Like that column reduction you will get same matrix element. So here you are getting the 0. So after performing total reduction, again you will get the same matrix for the node number 6, which is d. So here row total reduction is 0, but we have got the value until the cost until the c, that is 25. Here total cost is total reduction is 0, and m of c comma d is here given as a 0. So now 25, a c d is now 25. Then from the d, what is the another possibility? Only one possibility, that is b. So for this you have to calculate the cost next time. So here we are going to calculate the cost for this b. So already we reached from a to c to d. So after reaching that cost matrix that we have calculated here, this matrix we have calculated, that is the matrix we are going to use for now. So this is the matrix that related to the d. So now we have to perform again same reduction when you are reaching the d to b, right? So d to b means here we have to take the value from m of d comma b. M of d comma b is here 0. Okay, then we have to make d row and b column is infinity. D row and b column is infinity. So initially here you have 0, and this is the position. So now we are making that column and row are infinity. Then b comma a, m of b comma a should be make as infinity, because after reaching here second time you should not visit the a. So we are making that position as infinity. M of b comma a as infinity. Now you perform the total reduction. Here all the position are infinity, so nothing will be changed, okay, in the column reduction and the row reduction. So here nothing is total reduction cost, so it is 0, right? So now we have to calculate the cost of 7. Cost of 7 is cost of 6, and total reduction is now 0. Okay, here is also nothing, column reduction also nothing. So 0 plus m of d comma b is also 0. So that's what given here. Cost of 6 is 25. So finally you got the 25. So this is the cost of 25. Now there is no other possibility. So this is the path, right? With the cost 25, we got the shortest path to this tour. So now A to C, C to D, D to B is the thing. So again he will go back to the A for to reach the hometown with the cost of 25. So this is the traveling salesman problem by using the least cost based branch and bound method. Thanks for watching.